Hello everyone, in this video we are going to solve a first order problem. The question is asking to find a steady state response of the following differential equation that is given to us if the input is a step function with constant b. To find a steady state response, we are going to find a transfer function. We have the input, then we can have the output. So the first step is to take the Laplace transform of this differential equation. If we take a Laplace transform of this differential equation, I will have tau s xs plus xs a, and then this ut is a step function with a magnitude of b. So the Laplace of that step function would be b over s. If I rearrange the equation, I will have tau s plus 1 equals AB over S. Xs is the response of the system or the output. So I have AB as tau S plus 1. If we were to find the entire response of the system, I had to simplify this fraction and use the fraction expansion theorem to change it to have an inverse Laplace to change it in the time domain. But the system only asks for the steady state response, so I can use the final value theorem. So if I use the final value theorem, I can stay in the Laplace domain and find the steady state, or find xt at t goes to infinity. It's just simply limit s, my function here, and s goes to 0. So if I cross out these two at 0, the steady state response of my system is AB.